Hi everyone. So welcome to the new video on the topic of solving the NCERT questions in chapter 1 of your science class 9, right? So we are solving the questions and this is the second part of this video. We have already made a first part and we did till question number 1 in that part, and this is the second part of the video. So hope you have seen the first part, and if you haven't, please go on. And today, let's begin solving the questions from question number 7 from your NCERT book. And if you like the video, please hit a like button and subscribe to the channel. Let's begin. Let's begin our work, right? So the question is, gas fills the vessel completely in which it is kept, right? So that means basically you have to like give reasons for these, right? Why it happens that when a gas is kept in a container, let's draw a container like this. So when a gas is kept in a container like this, it like fills up the whole space. Why this happens? So first of all, let's understand the reason behind it. Basically, the force of attraction between the molecules of gas, like they have the negligible, force. So they don't stick to each other so tightly because they have the least force of attraction, or negligible it is. So it keeps moving in all the space of the container, increasing the kinetic energy. Remember, the kinetic energy is energy in the motion, right? So the kinetic energy is higher. That's why the the gas fills completely the vessel in which it is kept. So you can like write the model answer like this: the force of attraction between the particles of gas is almost negligible. Almost negligible. That is why kinetic energy is high. Kinetic energy is high, and that is why it takes up the complete space. It fills the complete vessel. Exactly. Now, let's move on to the next question of question number 7. So it says a gas exerts pressure on the wall of the container. Again, this has the very like pretty same logic. If you will like look it from the context, it has the pretty same logic if you look it through the context of the gases, because they have very less intermolecular space, right? So they goes to each and every end, and that's why they exert pressure on the wall. So you can say that the of the motion of particles is a random. Motions of particle is a random and having very high speed and having very high speed in the gaseous state. In the gaseous state. Due to this random movement, the particles hit each times on the wall of the container and the pressure get exerted. Okay. If you want to like look for the proper model answers, you can like find it in the description. We are like keeping the answer PDF in the description as well. You can check it from there. Now, let's see the third one, the third question for which the reason is asked. This one is pretty easy. You just have to prove why something is like solid, right? So a wooden table should be called a solid. Exactly, that is a solid, right? But why is it called a solid? So the reason behind it is very clear. That what are the characteristics of solid? We all know, right? That it is the force of attraction between two solid molecules are very high. They have very less intermolecular space, so that maintains the shape of the object. And if something has a rigid shape and they have very less intermolecular space and high force of attraction, that is a characteristic of a solid, right? So you just write this thing that wooden table has a very high force of attraction, very high force of attraction, and very less intermolecular space. Intermolecular space. Intermolecular means the space between two molecules, right? Intermolecular space that makes it rigid and keep the shape, keep the shape intact. Keep the shape intact. That is why it's a solid. Intact. That is why it's a solid, right? Let's see the next portion of the question. It is, we can easily move our hand in the air, but to do the same through a solid block of wood, we need a karate expert. Exactly. See, again, the all question, the all reasoning are only based on the characteristics of matter only. Let's see why this happens. So, in air molecules are very, very far from each other, right? Very, very far from each other due to the negligible force of attraction, right? Due to the negligible force of attraction. So our hands, our hands get gets sufficient our hands get sufficient space to move, but a solid block, a solid block, but in a solid block, the force of attraction is very high, right? Very high, resulting very less space, very less space between the particles. The particles, and that is why, and that is why our hands can not pass through, can not move on a solid, right? So this is what your answer for this one is. See, now you do not need to write the same answer. Also, as I've told you that I will like put the PDF of all the model answers in the description. But again, you don't have to write the same thing. It is just you need to understand the concept. You can mold the words according to your choice. Exactly. But remember the key terms like the intermolecular space or the force of attraction, the particles, the distance, these things are important to form your answer, right? So like you can use these important keywords and make up your own answer with the same logic. That's also like perfectly fine, right? Now let's see the next question. So The next question is question 8. Liquids generally have low density as compared to solids. But you must have observed that the ice floats on water. Find out why. See, generally, the solids, they have more density, right? And that is why they sink in the water. But the ice, it's a solid. But like if you will put it in water or any kind of liquid, you can just do this experiment. You can put the ice into the water and you can see that it will float. It will not sink. Why? What's the reason behind it? How, does this happen? We have to like answer the logic for it. Let's see. Clearly, when the if you will look at the eyes, liquids, as we all know that liquids have lower density as compared to solid. But in the case of ice, lower density is not the reason, right? The case in this case, the reason of the is the same, the cage like structure of ice. You see the cage like structure of ice, it like looks something like this. Okay, right? It's basically kind of a cube, right? So the cube like structure of ice, like it helps to make the vacant space. It helps to make the vacant space, and that is why like it can float on water. So to write the model answer, you can say that liquids have lower density. Liquids have lower density as compared to solids. Water is also a liquid, so it should also have less density, right, than that of a solid, that is in this case ice, right? That is ice. Now, but the case is not so, and the reason for the same is the cage-like structure of ice. The cage-like structure of ice. This is one of the reasons why the solids float. You can even explain that the presence of vacant space between water, that is H2O, water, molecules, when they linked in ice. The number of space is comparatively less in water. The number of space is comparatively less in water. Let me show you something with the help of a diagram. Let's see. So, you know about the molecules of water, right? That the water is made up of two molecules, basically. Two hydrogen atoms and one oxygen atom, right? Two hydrogen atom and one oxygen atom, that makes it H2O, like this, or you can say like this, OH, right? Now, if you will see that this is the molecule of water. But when it forms the ice, when it becomes ice, you know, the structure is like the cage-like structure. So it can go like this. Again, one oxygen and two hydrogens. Again, one oxygen, two hydrogen, right? If you will notice, the space between these structure are like more. If you will notice, the space between these structure are more. That means it has like less density, right? If you will see the liquid have less density as compared to water, and one of the reason is that their molecules have space in between, right? But as compared to the water, the ice, due to the structure of ice, it has more space in between. So that is why it floats on water. The water in the case of solid is more, water in the case of ice is more dense. Okay. Now let's see the question number 9. In this, like, you need to convert, right? Convert the following temperature to Celsius scale. Now Celsius scale you need to convert from the Kelvin. Now what is the Kelvin? Kelvin is the SI unit of temperature, SI unit of temperature. So first of all, you need to convert 300K, and then you need to convert 573K, right, to Celsius scale, right? Let's see, to do this, we have a formula. We can convert from the Kelvin temperature to Celsius temperature. That is Kelvin minus 273 is equals to your temperature in Celsius. This is your answer. Like, temperature in Kelvin minus 273K will give you your temperature in Celsius. So 300 minus 273 is gonna give you how much? This will be, yeah, 273, 300 minus 273K. 273K is going to give you 27 degrees Celsius, right? Try the second one. It's going to be 573K minus 273K. Easy peasy. That's going to give you 300 degrees Celsius, right? Now, to do the vice versa, because the next question, as you can see, the next question is to convert the following temperature to Kelvin scale. Now you need to convert it into the Kelvin scale, right? Let's do it. Again, it's very the question is easy. You have to add now. Okay. So to Kelvin scale, to convert the temperature into the Kelvin scale, you need to just do the opposite of it. Okay. Let's see how you can do the opposite. So you know that T, when you want to get the Kelvin, when you wanted to get the 273K, when you wanted to get the degree Celsius, temperature in degree Celsius, you just minus it. Now, if you want to get the Kelvin, the temperature in Kelvin, what you need to do, you need to plus it. So Kelvin will give you 273K plus whatever the degree Celsius is given. So 25 degrees plus 273K, right? That's going to give you 102 Kelvin, I guess, right? Not 102, come on. This is 273K, 273K plus 25 degrees Celsius, right? 5 times 3, 5 plus 3 is 8. And that's going to give you your 298 Kelvin, right? 373K. So add just 273K to it and see what happens. Yeah, So this is 646 Kelvin. Okay. Now let's move on to the question 11. That is, give reasons for the following observations. Naphthalene balls disappear with time without leaving any solid. See, this is one of the very, very much important questions that like you should know, right? And what is and why is this reason? Remember the process of sublimation. Remember the process of sublimation where the solid directly changes into liquid. Solid directly changes into liquid. That is the sublimation, right? And you can say that it happens due to the process of sublimation. We can get the smell of perfume sitting several meters away. And why this happens? Because obviously that air particles moves freely in the gas particles move freely in air, and that is why making it more easier to reach out to us. The same, it's like the same question we did for the food one. Remember the smell of hot sizzling food, it will have the same answer because the logic in the question is same. It's just two different things. Now, arrange the following substances in increasing order of force of attraction between the particles. We know that the solids have the like most space of attract, like most force of attraction in them. Then we have liquids, and then we have gas, right? So this will be your water, sugar and oxygen. So sugar will be the first one, then it will be your water, and then it will be your oxygen, right? Exactly. Now, what is the physical state of water at different temperatures? So we are given few different temperature. What will be the physical state of water at that point? So 25 degrees Celsius, right? 25 degrees Celsius. In this state, the state of water will be like you can say hot, right? You can say hot or boiling, right? Hot you can say or boiling, right? Now 0 degrees Celsius, it will be obviously and ice, right? It will be, although ice the ice the water will remain the same, whatever, like if it is ice, it will be ice only. It will maintain its temperature because the ice water freezes below 0 degrees Celsius. So that is why at 0 degrees Celsius you can see it will maintain its shape of ice. Now 100 degrees Celsius is the boiling point of water, and there will be a transition from water to water vapor. At this point, there will be a transition from water to water vapor. Exactly. Okay, now question 14. Give two reasons to justify water at room temperature is a liquid. Why, like water at room temperature is a liquid? You have to give a reason for that. So clearly, reason for this is at room temperature. Generally, the temperature is more than zero, like temperature is more than 0 degrees Celsius and less than 100 degrees Celsius, right? Because if it will be less than 0 degrees Celsius, that will be the freezing point, and the water will change into ice. And after 100 degrees Celsius, it will be the boiling point. So it will be boiling or transition into steam. So water at room temperature, it will only be the liquid, right? Now, an almirah is a room temperature, is a solid at room temperature. Again, see, different substances has a different melting point, right? Different substances has different melting point. Like iron. iron is a metal and is a solid. So like if you will put a really high temperature, really high temperature on it, then it will start melting. But at the room temperature, it is obviously not so high. That the temperature is not so high, like not to 30. Generally the solid like iron, it melts around to 200 to 250 degrees Celsius. So the room temperature is not that much, right? So that is why it remains solid only at the room temperature. Now, why is ice at 273 K more effective than the cooling water at same temperature? See, the ice at 273 K is actually zero. 273K is zero. Okay, 0 degrees Celsius, and 373K is 100 degrees Celsius, right? So at water at is ice at room temp like 0 degrees Celsius, okay, it is more effective in cooling than the water at the same temperature. As I've already informed you, that ice has more space of like the more space in between, and it has less density, so it gives the more cooling effect as compared to the water at same temperature, because it will have more density and more space, less space as compared to the ice. Now, what produces more severe burn, boiling or steam? Like this question, now you need to do these last two questions because it's very easy and we already discussed it many times. Also, like you will be given a figure, you will have to like change uh, in its state. You have to write down the change whatever happening in the state. Remember the diagram that we were doing, that we did while doing the chapter, from from solids to liquid, it's melting. From liquid to solid, that's freezing. From directly solid to gas, that is sublimation, right? We did that chart, so you can refer to that chart only, and that will help you a lot, right? Also, we like completed the whole chapter questions. In the next part, we'll see some important questions from this chapter. Till then, if you haven't watched the explanation video of this chapter, please go and watch it. And that is it for the video. Thank you so much. Bye bye.